The following table lists U.S. advertising volume in millions of dollars by medium in the year 2008. So there's what, 1, 2, 3, 4, 5, 6 different media here, and this is the amount of money spent on advertising in each of these media. So yeah, it's in millions of dollars. All right. So if we're trying to construct a probability distribution, then kind of what we're doing here is we're saying if we pick $1 at random that was spent on something, some sort of advertising, what's the probability it was spent on television, or what's the probability it was spent on magazines? And this is a good example of a what do you call it? Empirical probability, that's what it is. I blanked out for a second. So essentially what we're going to do is we're going to look at all of these as our sample space, and look at, each of these millions of dollars are equally likely. So what I would want to do is I'd want to say, okay, how many outcomes, what is the size of my sample space here? To find the size of my sample space, I would need to add together all of these numbers. Let me scoot this over a little bit so I can see. I'll get 65137, 25059, 9727, 9501, and 3964. Alright, when I hit enter, I get 141,968. 141,968. So if I wanted to figure out what is the probability that any given random dollar was spent on television, what I'd want to do is I'd want to take the amount of money spent on television, 65137, divided by this 141,968, and you can see there's a 45.88% chance, or 0.4588 is the probability that a particular dollar was spent on television. So part A asks us to construct a probability distribution for the probability that $1 of advertising is spent on each medium. So I would just go ahead and say, here's the medium, and here is the probability. So I'd first start off TV, that's the one I just figured out. That one was 0.4588. Oops. Then we have magazines. 28580 divided by 141,968. Gives us 0.2013. I'm just going to keep this to 4 decimal places. Newspapers. We have 25059 divided by 141,968. 0.1765. Internet, which is 0.0685. And lastly, outdoor. I assume that means things like billboards, and maybe you occasionally see trucks driving around with a sign on it or something. Alright, that's 0.0279. So that would be our probability distribution. Like I said, it just gives us all the different things that the money could be spent on with the corresponding probability. I could check here that everything adds up correctly. Let's try this. 0.4588 plus 0.2013, 1765, 0.0685, and 0.0279. And you notice they don't quite add up. Right, that's because I forgot radio. Let's add that on there. 9501 divided by 141,968. That's 0.0669. Alright, now let's try adding these together. I already added all the other stuff, so let me just start with 0.933. That's all the stuff except for radio. Add on radio, which is 0.0669. Add that in there, and you can see it doesn't quite add up to 1. And but you'll notice the error here is in the thousandths place. And that actually doesn't concern me at all, because when I was rounding each of these, I was actually rounded down on every single one of them. And So when I round down, that essentially introduces a little bit of error, and the number I wrote here is a little bit too small for each of these. And when I add them all together, you can see it sums up to something just a little bit too small. I'm not worried about that. I think that's just the rounding errors that are occurring, that are showing up there. So that's nothing alarming. I would still say that those add up to 1. Alright, find the probability that $1 of advertising in the US is spent on newspapers or magazines during this period. So, newspapers, we'd see it's this probability, and magazines was this probability right here. Since there's no overlap between the two of these, technically I would need to do, I would need to use the union rule here. Magazine, union, newspapers. If I was to find the probability of the union, I would have to take the probability of the first plus the probability of the second minus the probability of their intersection, right? Magazine intersect. It's supposed to be an intersect. But this number right here is 0. If $1 was spent on newspapers, it wasn't spent on magazines. In other words, they're mutually exclusive. One of the things we'll see is that when we're talking about mutually exclusive events, the union rule, there's actually a simpler way of doing it. You can see we just add the two parts together. So we can just say that this is 0.2013 plus 0.1765, adding those together. 0.2013 plus 0.1765 gives us 0.3778.